My name is Justin Gao, application engineer here at KETIV. So here's a little agenda of what we're going to be going over today. First, we're going to go over an introduction of myself, what I do here at KETIV. Then a little overview of what is model states if no one is familiar with it. How we could apply model states into your workflow. Christina already put up the poll questions. So once we get to that slide, I could read your answers and see how you guys are using it or if you are using it. And then we'll go straight into the demo where we're going to be going over model states at a part and assembly level. And along the way, I'll give you some tips and tricks on what I've learned when I've worked with model states. And at the very end, we'll have a little Q&A so you guys can get all your questions answered at that time. And when I'm looking through or when I'm going through the demo, I'll see some questions, and if I might answer some along the way as well. Okay, so let's get this show on the road. So a little introduction about myself. Like I said, I'm an application engineer here at KETIV. I've been here for a little bit over 4 years now. Started interning here back in the day. Eventually got a job here right out of school. Went to Cal Poly Pomona. Graduated with a mechanical engineering degree. So some of the projects that I've been working on recently is I've done a lot of automation projects where I would develop configurable models, mainly in Inventor, and then we would automate it to speed up workflows for engineers. Most recently, I've been on an 11-month project where I was at a customer on site, and I helped them convert their 2D to 3D. So I came up with their standards, organized their file structure, gave them the best practices. So for their engineers, they have predictability within their workflow. So that's something I do as well. Doesn't have to be on site. We also do that remote. So if you guys ever need help with any of that, feel free to reach out. We can help you with that as well. All right, so what is a model state? If you are on a version of Inventor 2022 or newer, that's something that they added, which has been a pretty powerful tool. And a lot of people really like that you could do model states now. So what it is it will give you different representations of your model if you set those different states. Before, they used to have something called VReps, which wasn't as good as model states, in my opinion. It did get some of this stuff done, but I think model states is a lot more powerful. You have a lot more advantages, and then you can manipulate things a lot easier. So why model states? Why is model states so good? So number one pro thing that I've seen about model states is you can organize different manufacturing process all under a single part. So for example, if you start with a blank and then down the road it gets punched, you could show that within one part versus showing 4 different parts. And especially if it's all under one part number, your organization becomes much, much greater. You can give accurate representation of models. So in some cases, you might have a model that, for example, it might look flat when you create it, but in real life, how it interacts with different geometries or different things, it might not end up being flat. It might be curved a little bit. It might have to conform to different shapes for it to give it an accurate representation of how it might be in a realistic situation. And that goes into the second one. You can manipulate models to give them a realistic look. And on top of that, you can do some automation. So let's go ahead and get into the poll questions. Christina already put them up earlier. So the first questions are you utilizing model states if you are on a version of Inventor 22 or newer? I have a 47% yes, and then 53% no. So hopefully we can get that 53% no to go down a little bit, and then hopefully you can start utilizing model states. Next question was a multiple choice. If yes, what are you using model states for? 22% says sheet metal bending, 31% says manufacturing process, and 72% says other. So super curious about what you guys are doing there. So looking at the chat, I see someone said that they don't have it yet. So once you upgrade from your version of Inventor to 2022 or newer, hopefully we can get you on that. All right, so that's good for the poll questions for now. Let's go ahead and jump into the demo. So the first demo is going to be a kind of a walkthrough of the thought process that you have to go through when you're creating model states. And then the second example, we're going to actually create a model state. And then we're going to go over some tricks along the way. So in this case, I chose a shower curtain. The reason why I chose a shower curtain is when you lay it out flat, that's how it might get manufactured, right? So when you create a drawing for a shower curtain, fabric acts smooth when it's laid down flat. But in real life, it doesn't interact like that, especially when you put it on a shower curtain rod. When you fold it, bend it, all that stuff, it can take on pretty much any different shape. So in this case, you might manufacture shower curtains. So when you do it, you start with a blank. So in some cases, you might not even have these holes punched in here, and then that might be a model state. In this case, I just showed it like that. So if you're going to be manufacturing a shower curtain, start with your blank. If you fold the edges, you could fold the edges using either sheet metal and manipulate the rule so it doesn't deform like sheet metal. You can also, under modify, you can use a bend tool right here. That would be the first step, and that might be different model states. In this case, I didn't do it like that. I wanted to give an accurate representation of how it might look within an assembly. So when I created my model state, right click, and I copied it and pasted it. I created a new one right here and I renamed it folded model. And this is what my folded model looks like. So I wanted to give a representation later down the road that the shower curtain, when I pull it all the way to the side, this is what it's going to look like. So then when I went next to the next assembly up, I have my main assembly here, which is the flat shower curtain. And then on top of that, I made an assembly by adding these rings to make it a little bit more rigid at the top when it's sliding on the rods. So now this is my finished assembly. This is how it would go in the packaging. And this is how it would look if it was laid out flat. But like I said, when you move the shower curtain in real life, it doesn't interact like that. So in my representation, what I did is my shower curtain, if you expand it, I switched the model state from primary, which was the default flat one, to a folded model. And what I also did was I suppressed all of the constraints that I had on those rings and suppressed them. If I don't suppress any of these, but I suppress the rings, you're going to see that I'm going to get a lot of health doctor stuff saying like, hey, you turn off the rings, but these mates are still here. It's getting constrained to geometry that it doesn't recognize. So the easy bet, just turn it off as well. And you're going to see the health doctor up here disappears. And what I did was, since this is just going to be a representation, I added a couple more rings to the edges. So when you see it from the assembly, it looks nice and neat. So now when I jump up to the main assembly, which is pretty much a little bathroom layout with a rod on it, you're going to see that I don't care about how the shower curtain looks when it's flat. I want to see how it interacts in real life. So this is a realistic representation of what it would do. You can slide it back and forth, but it will, if you want, so it spreads out, so it covers the entire bathtub, that would be another model state that you would have to start at the very beginning of where the shower curtain is. So if you want it a little bit wider, like I said, you could right click, copy, and then it will create a new one. And then you can manipulate either the sketch, manipulate some parameters, create a brand new sketch, and then that will create that model state for you. So it looks a little bit more spread out if you wanted to get all the way up here for it to do that. Alrighty. So that's the walkthrough of how it's done. Let's go ahead and go into a different example. So in this case, what I have is this just a flat part right here. I named it mesh because this is going to be a representation of a screen mesh. So it might be, for example, it could be a strainer, it could be a filter. So in this case, we're going to use it as a filter. So if I zoom in, I just put a material on there. So it's just expanded metal. So it gives it that look like it is some type of mesh. And we want this to act like a filter. So right here under model states, you're going to see it says primary. That means it's just the main one. If you're in Inventor 2022, it doesn't say primary. I think it comes in as default. So even though the names might be a little bit different, it means the same thing. So if I create a model state right now, it's just going to call it primary one. So I might want to name it folded model. Give it something that has some meaning behind it. If you keep it pretty generic, it might be confusing down the road when you get to an assembly level what it's going to be named. So once I get into folded model, now I could start creating a model state. So a little tip and trick, if you're entering iProperties, in this case right now, if I go over to my primary model state and I say, hey, let me put in an iProperty, maybe I want to say that this is aluminum 0.125 thick. As a comment, just say I want to name it also mesh here. I press apply. I'm in the primary. When I jump over to the folded model, you're going to see my iProperties don't carry over. So in order for it to carry over, let's go ahead and delete. Let's get out of that model state and let's delete it. What you have to do is before you create model states, you want to be able to insert your iProperties. So when you make a copy of it, you're going to see it carry over. So here it's there. If I copy it, okay. So I switched over to that one. Let me rename it so we don't get confused on the road. You're going to see those iProperties carry over. In some cases, between different model states, you might have different iProperties, then that doesn't really apply for it. But if it's going to be the same information, make sure you fill it out at the very beginning. That'll save you a little bit of time down the road. Okay, so now we're in the folded model. Let's just say that I want this filter to be a cylinder, because typically before model states, if you didn't have this function in there, how would you show, hey, this metal is going to be bending? Maybe you do another part, or maybe you have to suppress things on and off manually. But in this case, we're going to be able to create a model state to show that it's going to be folded down the road. So in this case, I'm going to use this little bend tool here. It's pretty neat, this bend tool. You don't have to be within a sheet metal environment to use it. And it doesn't deform like crazy, so you can use it right out the box without worrying about deformation on a lot of stuff. So in this case, here, I need to go back to my sketch. So I want to make sure I know this dimension because I'm going to make this a perfect cylinder. So 31.416. So if I just project these edges, start a line. And I know it's not straight. I'm going to use my perpendicular constraint. And now I'm going to dimension this. And I know it's 31.4. I know it's actually 4159, even though it says 6 divided by 2. So it's down the middle. Use this bend tool. Select the bend line. I already had my settings in here because I was playing around with it earlier. So I wanted a 5-inch radius. I want to bend 360 degrees in both directions. So now that I have it bent, now you can see that this is going to be a model state of what it's going to be down the road when it becomes an assembly. So if I switched it, here is my flat part before it gets bent. here's what it looks like after it gets bent. In some cases, you might use this size. Just say, hey, we're going to use this size sheet, but instead of bending it the way we bent it there, we're going to bend it in the horizontal direction. So easy enough. What we could do, copy this to create another model states. So even though this is folded model, I might name it something a little bit more descriptive. So it's bent in the horizontal. So I'm just going to say folded model horizontal. If I trigger that one, you're going to see it's flat because I made a copy of the primary and not the folded model. And then if I start a sketch here, so in this case, it's 6 inches. That's directly in the center. And then if I use my fold tool, this says 5-inch radius. It'll probably be much smaller than that. Just say 2-inch, for example. It's not going to close all the way, but you guys get the idea. So if I switch it over to this one, you're going to see that there's no issues. So here's my flat, and then here's 2 different configurations I could use of it. So just know also, when you're doing folded model, or when you're going into different model states, if you're changing the geometry drastically and you're projecting a lot of geometry from on your sketches, just know that if you switch back and forth, you might get some health doctor stuff pop up saying that it doesn't recognize some geometry because it might no longer be there, or you're referencing something that you might have cut out before or added something. So just know that, because, and then you might have to work around constraining things to the origin to get things to line up pretty good and make sure you don't have anything that's broken within your part. All right. So now if I go ahead and jump over to the next assembly up, what we're going to do is we're going to create a new assembly. So here's my new assembly. I already made a mesh ring. So place grounded at origin. I know that, hey, I'm gonna wrap my mesh around here and I'm gonna tack weld it in 2 places to make sure that the contour of that mesh doesn't move. So I have my ring there. If I go ahead and place in my mesh, you're gonna see that it came in flat. Usually it will come in to whatever is set as what it's set in the part level. So in this case, it's set as primary. So since it's set as primary, your mesh is going to come in flat. If you expand the mesh, you're going to see model state. It says primary there as well. So in this case, we know that we want to bend it to match the ring. So I'm going to use this folded model. And you're going to see that I'm going to be able to constrain it to that. So in that case, I think I made my ring too small actually. So let's go ahead and let's go back and change that real quick. Radius was 5, so it actually needs to be 10. So in this case, I will start constraining it. So there. So now we could weld this and then match this. And then later down the road, if you cut holes into your mesh, so let's just say this is the finished assembly here. You can continue to make model states within your assemblies. So here's primary. If we do a copy of this, just say somewhere down the road, we're going to be making some cuts into this model. So I'm just going to generic geometry, just a rectangle. this might be, even though it shares the same part number, in this case, we just might call this a filter. You could switch to that model state to show like, hey, down the road, we're going to cut it, but we don't want to show it there. We want to show it here. You can house everything within that one assembly. So let me go over a little bit what I did again. So it's not too confusing. Let me know if it is confusing at all. So what we did was we started off with a blank part, no logic behind it or anything like that. What we can do is we can add a little bit of parameters in there. That's something that my colleague Eric did a couple weeks ago, controlled model states with some iLogic and using parameters. So this one is just a dump solid because we're trying to keep it simple. If you have I properties, fill them out beforehand. So when you make copies of that model state, it carries over. Once you jump into your model state, manipulate it to however you want. In this case, I'll add a different scenario. If you want to get this coded, you could change the materials in this model state. So maybe this was steel when you're going to zinc coat it so it doesn't rust. You could put that there. And then in that case, if things change, you could manipulate the I properties in here manually. So maybe you want to override the weight. Model states could hold that as well. The only thing that model states, I haven't figured it out, and I don't think it can handle, is if you do appearance changes. So the last customer I had, they wanted to show different colors for different types of fabric that they used. That was something that we couldn't figure out for the appearance. We could do it with the materials, but then you have that material association with it. So maybe you have to create a unique material, a unique color, and then you could apply it that way. That was the workaround that we figured out for it. So that's the only inconvenience that I've seen so far with model state. You can't assign appearances and they carry over like that. So what I did was we create this model state right here. We created another model state to show that, hey, this blank could be used in multiple ways. And then when I went over to the assembly, we have our model state, which is primary, which is going to show this case where we have the part switched over to the folded model state. This mesh ring is still in the primary model state because it doesn't have any model states underneath it. And then what we did was we created another model under the assembly. So when we create another model state under the assembly, oh, it turned off here. Yeah, what we want is actually this one to be on here, and on the primary, we wanted it to be off. So that's something to note. There was some cases where I accidentally made stuff in the primary and not in my model state. You can go back and manipulate it. So if I made it in here, I could say, hey, actually, I want it off in the primary, but in my, let me name it so we can refer to it. In my cutout model state, I want to make sure the cutout is there. So actually, let me see. I know in Inventor 2022, what I noticed was when I turn things on and off between model states, I lost some information alongside with it. So in this case, just say I wanted this to be 5 inches and I wanted this to be 3 inches. When I turned it back on, just say you wanted it actually in the primary and you suppress it, and then you open up that sketch. In some cases, like here, it carried this 5 inches over, but it didn't bring the 3 inches over. So just know that if you turn things on and off in different model states, some of the values are going to get manipulated because it doesn't recognize that the geometry is there. So if you do mess up on that, make sure you go back and fix that. That's another thing that I've noticed. Kind of weird, not sure why it does that, but it does do that. Alrighty, so let's go ahead and go back to the PowerPoint. So like I said earlier, this handsome man right here, Eric Paul, did a model state KVA a couple weeks ago, and he utilized that with iLogic. So anything that you learned today, you could apply that with iLogic. And it is on our KETIV YouTube page. So some contact information if you have any questions. That's my email. That's the KETIV support number. That's my LinkedIn. If you want to connect, have questions, feel free to reach out to me on there as well. Chances are if you give a call, we'll get back to you a little bit faster. So let's go ahead and jump into the Q&A. All right. So first question from Eric, can model states be applied to library components without creating an I part with different description? But geometrically, they are the same. For example, gauges, different pressure ranges, connection size, and brands. So that's an interesting question. So for example, you were using gauges, right? It depends on what your engineering team is supporting currently. So if we're talking about sheet metal gauges, between just say 8 gauge to 10 gauge to 12 gauge to 16 gauge, internally you might have a part numbering system that takes into account those different gauges. So if each part number is different for each gauge, then it might not make sense. It might get a little bit confusing. So in that case, I would say no, don't do that. If you have unique part numbering, if you're creating a master asset, you can set that as different model states. They say, hey, each model state is going to represent a gauge, and then I have parameters to control the various lengths and widths of that material. And you just want to house all of that within one part, then yeah, I would say, yeah, that would work. You wouldn't have to create an I part for that. You would be able to control it with the model states, with iLogic too, actually, for that case. So next question, Eric has another question on assigning appearances in MS. If you have the appearance in the material library, would you be able to apply it? So we did create unique materials. You were able to apply unique materials to different model states, but if you create unique appearances and not materials, you won't be able to put those appearances on there between the model states from what I've seen. So in the case where just say you might have if you're using, for example, a PVC pipe, and then your manufacturer produces blue PVC pipe, but you might get another PVC pipe that's white, even though it's the same PVC, they're different colors, you're going to have to create different materials and name them accordingly, even though it is the same material. A little bit confusing on why that is, but that is the workaround for it. Gabriel asked, can you use it with sheet metal flat patterns? Yep, you can use this with sheet metal flat patterns. We've done that before. Whether you start with the flat pattern first or you do the folded model part, either way, you can work either way, create model states for those different flat patterns. And that's the most common utilization for sheet metal parts, actually. So whether they're bends around contours, drilling into different plates and brackets to show the different hole locations, you can do it all there. So how do you handle revision changes when one substate or part number has changed yet not the others? So in this case, I'm guessing you're talking about maybe utilizing it with Vault. If you are doing it in a way that, just say the blank doesn't change, but one of the model states under the blank, so maybe you change the whole location changes, it would rev up the entire part number because everything's associated under that part number. If you didn't want to associate it under that part number, or if you didn't want everything to rev up and you only want the model state to rev up, I don't think that's something that can be done at the moment. That's actually something that my team is actually looking into to see if model states are unique within Vault, to see if we can automate that. So that's a good question. At the moment, from what I've seen, everything is linked under that part number. If you didn't want it to rev up and you did make a change, like just say accidentally you located a hole in the wrong location, what you could do is do a quick change if you're in life cycles and then change that and check it back in, and the rev won't rev up. Or if it revs up, you can always push the rev back and just put a comment about it. All right, so Scott has a question saying, can these part states be used in a drawing for overlays, like an assembly can? Yeah, so you can actually activate different model states within your drawing. So in that case where, let's say for the mesh, if you only want to show the blank on the drawing, just make sure you choose that primary model state where it was just a flat piece of mesh. But if you wanted to show like, hey, in the next assembly over, it's actually going to contour like this, you can activate that model state and say, hey, let's put it in the drawing and dimension, say we need to hold these critical dimension of this radius or this diameter, or so on and so forth. So here's another question from Sohab. Sorry if I pronounced that wrong, but is there a way to automate the motion of an adaptive part? Say a cable manually changes the position of other parts in the assembly to see the cable change its length. So they used a cable as an example. So if a cable length changes, you would want the model state to change. That right? A little confused on what you're saying, but if you're talking about motions, like for example, you want a cable to move, just say 180 degrees, and then you restrain it that way. Yeah, you can use model states to suppress a constraint and then create a new constraint that shows that motion. Alrighty, I'll give it another minute for any questions. Eric, I see you say you're referring to pressure gauges. Feel free to email me on that one. I'm not really sure what you're referring to, but if you email me here, I'll put my email back on the screen. Yeah, maybe we can go a little bit more into depth about your questions and we can figure something out. Oh, so you're saying your dial's a little bit different. So in that case, what you're talking about where you have different ranges, yes, you can create different model states, but like I said earlier, if you have different part numbers for those different ranges, it might not make sense to combine everything, because then it becomes a part numbering disaster if you try to combine different part numbers into one part. If it's not that case, you're going to be able to set those different ranges that you have there as different model states, and there is no limit to how many model states you can have in one part. But if there's a lot of geometry going on, it might slow down a little bit. But alrighty, if there's no more questions at the moment, feel free, if you do down the road, send me an email, give us a call. We'll figure it out. Once this becomes a YouTube video, if there's questions on there, usually the KETIV team's pretty good at answering them. All right, so Hob, I see that you got back about the cable length. So cables is actually something pretty tricky, especially if it's being bent in if it's like a compound bend in it, so it doesn't bend only in one plane, it might bend in multiple planes. That's what I've noticed. It takes a lot of time actually to get an accurate representation of how a cable will flow. So what I suggested actually for one of the customers that was dealing with cables was, instead of trying to show it in the part itself, what you can do is you could sketch it in at the drawing level. So you can create either a sketch symbol, create unique sketches, or you can even create like an overlay, like someone was talking about earlier, edit a part, or put it in an assembly, create an overlay, so you can see the pathing of that cable. But cables and things that are getting bent in multiple planes can get very tricky very fast. All right, here's another question from Ray. Have you seen the use of model states being used to show different assembly breakdowns between production drawings and part drawings for operator manual? So if you're talking about assembly breakdowns, like maybe suppressing some parts here to give better visibility, that's something you definitely can do. So when you create the drawings for it, you can get more detailed views. That's a good way of using model states that it's kind of unorthodox, but I love doing unorthodox stuff in Inventor. You can do that, definitely. Have I seen it done? I recommended it actually to a customer, but haven't seen them do it. So I haven't seen any of their output. But yes, you can do that. If you're suppressing certain parts, certain assemblies, sub-assemblies for that matter, just to zoom in so you can get a really good view. So when you put it in your drawing, that you can get an accurate depiction so it makes sense for your operators. By all means, do it. Reach out to us if you have any questions, whether it's related to model states or not, or if you want to know more about model states or want a version of Inventor that can support model state, reach out. We're more than happy to help. So on that note, I hope everyone has a great rest of your week. Stay safe out there. Stay cool if you're in California. It's been pretty hot. And yeah, Christina, I'll go ahead and turn it back to you if you have anything to say.
No, thank you everyone for joining. We will see you at next week's session. That one is going to be around Autodesk Fusion 360. So we'll see you guys all then.
All right. Bye, everyone. Have a good one.